Hello guys, welcome back. This is Dr. Hadi here. Today's topic is definitely the mechanism of enzyme catalysis. We have already discussed that enzyme speed up a chemical reaction. Enzyme speed up a chemical reaction 1000 times more faster than without enzyme. अगर enzyme मौजूद है तो reaction बहुत ज़्यादा speed होगा. If the enzyme is absent, the reaction will be too slow. This is fine. We got this. Then we came to know that what enzyme actually do in order to make the reaction that much faster. So we got the answer that there is a concept of energy of activation. Energy of activation we have already discussed. What is energy of activation? So enzyme actually decrease the energy of activation. In this way it increase the speed of reaction. Now in today's lecture we will discuss how enzyme decrease the energy of activation. I cannot repeat the energy of activation again. Most of the students, most of the viewers might be thinking that if we have some idea on energy of activation, so it's not possible. You can just type energy of activation by Dr. Hadi, you will get it. So today's whole lecture is based on how the energy of activation is decreased. Remember, whenever the energy of activation is decreased, the reaction speed will increase. These two things are always inverse proportional with each other. If you decrease the energy of activation, the speed will increase. The reaction speed will increase. If the energy of activation is increased, the speed will decrease. So up to this point we are clear. Today's lecture will be the mechanism of how the activation energy is decreased. Okay, come to the word catalysis first. What is meant by catalysis? The catalysis can be defined in two ways. The first one is simple, means when a substrate, this is your substrate and this is your enzyme. When a substrate attaches with the enzyme, it is converted into product. This is called catalysis. Second, when an enzyme speed up a chemical reaction by attaching the substrate at the active site and converting it to product, this is called catalysis. So catalysis can be defined in two ways. In catalysis, we must know this sentence: substrate must combine with the active site. Enzyme, we have the enzyme active site. There's a pocket like where substrate is attached. If your substrate is far away from enzyme, then the reaction will not take place. In order for the reaction to take place, the substrate must come closer to the active site of the enzyme so that the substrate attaches. Without attachment, product formation is impossible. So the first thing is substrate must come close together. If it is far away from enzyme, it must come close together. Number one. Number two, once the substrate come close together, it must attach with the active site of the enzyme. The active site of the enzyme must have some groups, charge groups, so that the substrate can attach with these charge groups. Otherwise, without these charges, without these charge groups, the substrate molecule may not be able to attach. So this is the second requirement that must be there. So this is the responsibility of the active site, that it generate positive charge so that positive negative charge, so that the substrate attaches. This was second. The third one is the proper orientation of the substrate molecules. Substrate molecules may not have proper arrangement. Substrate के molecules इधर उधर होंगे, मुख्तलिफ directions में होंगे, proper तरीके से arrange नहीं होंगे. Then what will happen? By the help of enzyme, the substrate molecules will get proper shape like this. Not like this. Someone is here, someone is here. Proper shape means all enzymes are oriented in proper direction, three-dimensional space. Now, if the reacting molecules are properly arranged, then there is a chance that the molecules collide with each other very frequently in a very good way. If they are not in proper orientation, they are not in proper direction, they are not properly spaced, they are not properly placed, then they may not collide with one another. If you want the molecules to collide with one another, then these molecules must have proper arrangement. So these proper arrangement can also lead to the catalysis. And these 3 points bring molecules together: proper orientation, attachment, and stabilization. But what is mean by stabilize? Stabilize mean that once something happens, then it remains in its position. It does not go away. This is called stabilize. Means if the pen, I have placed the pen like this, if it is not moving here and there, it is just stationary, I say the pen is stabilized. If it is unable to stand like this, it may go on the right or left, front or back, then I say it is not stabilized. So once the molecule is attached at the active site, it must be there for some time so that the reaction take place. This is called stabilization. These 3 points will lead to the decreased energy of activation, EA. Energy of activation. These 3 things. So we got this first thing. Now here you can see the diagram. We have an enzyme E, and this one is our substrate S. After some time, enzyme and substrate, they are together now, attached. This is called what? Enzyme substrate complex. We know very well up to this place. Once the enzyme substrate complex is formed, then the reaction will start, reaction will take place. As a result, the product will be formed. This is our product, P. This is our product, and this is our enzyme. Enzyme has been, enzyme's change is, enzyme shape is unchanged. You know, it has shape like this before the reaction, and after the reaction, enzyme still have the same shape. Enzyme is not utilized. Enzyme has just speed up the chemical reaction. So what happened actually? The substrate was converted into product. Okay, now what is here? We have another word, transition state. What is mean by this transition state? This is very, very much important for this topic. A transition state is this one. You have an enzyme, and this is your substrate S. Just I need your focus to be on the shape of the substrate. You see here the substrate shape is just like a rectangle. When it attaches with here with enzyme, this is now attached. The substrate is now attached. The substrate shape is little bit changed from the active site. So this is not properly attached. In order to to properly attach this substrate, we need to put some pressure on the substrate. सबस्ट्रेट के मॉलिक्यूल ऊपर कुछ प्रेशर लगाना पड़ेगा ताकि इसकी शेप चेंज हो जाए. Substrate shape must be changed. It was like this, substrate was like this, and now some of the stress will be inserted on the substrate so that the shape of the substrate is changed like this. Now here the substrate is a little bit curved. This curved substrate can now be very well fit here with enzyme's active site. This stage is of course called the enzyme substrate complex. Yes, it is complex, but this is called transition state. This is called what? Transition state. This transition state increases the energy level a little bit. So this transition state helps in decreasing the energy of activation. This transition state helps speeding the rate of reaction. This is very, very much important. And once the transition state is formed, it needs stabilization. Means maybe the substrate molecule revert back to its original position. So we need the substrate molecule to be in proper position and in proper shape so that reaction could take place. So it need what? It need stabilization. And now here the enzyme substrate complex is converted into product. I mean, this is the condition, is very necessary. Isko karna padega. Your substrate must get shape like this so that it can properly attach with enzyme. Then it is possible that it convert into product. This was the concept behind the catalysis, the overall concept. You know, you got what is meant by mechanism of enzyme catalysis. This was generalized. Now I will become a little bit specific, that in how many ways enzyme achieve these goals. In how many ways, कितने तरीकों से enzyme reaction को speed up कर सकते हैं. In how many ways enzyme decrease the energy of activation. In how many ways enzyme do so. So there are 4 well-known ways. There are 4 well-known mechanisms by which enzyme decrease the energy of activation, or by which enzyme speed up a chemical reaction. So before we discuss these 4 headings, I want every student to keep one thing in his or her mind, that attachment of the substrate with active site is necessary. Attachment of the substrate with active site is necessary. So we will be discussing here and there that how this attachment is facilitated. So number first, covalent catalysis. Covalent catalysis. This is one mechanism. In covalent catalysis, the active site, this is our active site. Look, this is enzyme. This is what? This is our enzyme. Okay, enzyme E, and this one is the active site. This one is the active site. You know, sometimes we say it is a pocket like, sometimes we say active site. So this is the active site of enzyme. Of course, there are many amino acids on the active site. 1 or 2 or more than 2 amino acids have the OH group, and this is our substrate. This is our substrate. What happens that the active site make a covalent bond with the substrate molecule. Means now we are going to break down the substrate molecule. Substrate molecule become R C double bond. In here we have, okay, sorry, I will make like this. This is our C double bond O C R and R. Fine. This is just a molecule, a general molecule. Now here is our oxygen. So oxygen is going to make a covalent bond with this carbon. This is what? This is covalent bond. This covalent bond is not permanent, it is temporary. It is what? It is temporary covalent bond. Means it will be formed where until the reaction is completed, this bond will be broken again. So for a little time, this covalent bond will keep the substrate in position. I told you in the beginning that we want attachment. So the substrate is finally attached at the active site with the help of which bond? With the help of covalent bond. This is another part of the substrate molecule that was released. So you don't focus on this R. Just check the substrate molecule is now attached at the active site. Of course, now the reaction will take place. Of course, now product will be formed. Product must be formed because the substrates have been attached. But the important thing was that this happened because of the covalent bond. And so this is first thing. And now the second one is catalysis by proximity. Okay, let me give you some example. Most of the digestive enzymes like trypsin, chymotrypsin, they catalyze by covalent catalysis. And most of the enzyme, one or two enzyme, they can apply both these four steps for catalysis. So you can't say that a single enzyme only perform by covalent catalysis, other enzyme only perform by catalysis by proximity. No, this is not possible. One enzyme can follow all these four steps. One enzyme can follow two steps or more than two steps. Now come to the catalysis by proximity. What is meant by catalysis by proximity? Sometime when we have enzyme, this is our enzyme E, and we have substrates, more than one substrate. Let's suppose this is one substrate, this is another substrate, and this is another substrate. We have more than one substrate molecules, and now we want these molecules to react with one another. This is a kind of reaction where more than one substrate molecules are used. Now these molecules cannot react together until and unless they are properly arranged and they come close together. These molecules must come close. Maybe one molecule is here, another molecule is here, another molecule is here. So these three molecules are far away from each other. They will not be able to react until and unless they come close together. So in this catalysis by proximity, this is another mechanism. In this mechanism, the enzyme is able to bring these molecules together because in this case, the enzyme will provide a space. So this is a proper space. This is what? This is a proper space or environment. Proper environment where these molecules can be brought together like this. Means one molecule is here, another molecule is here, and another molecule is here. Now the three substrate molecules, three different molecules are now close together enough. This is first. They are even attached. They are properly arranged. Means in the beginning when they were not properly arranged, there was not a chance of collision with one another. Molecule must collide with each other. Once the enzyme provide them a good environment so that the molecule can come together, now the molecule will be properly positioned. Mean they were a different direction, now the molecules are properly placed. When the molecules are properly placed, they can collide with one another. So because of this collision, the reaction will be speed up. Because of this collision, the energy of accretion will decrease. Because of this collision, the rate of reaction will increase. So we got our target, bringing molecules together, proper orientation. This all happened because enzyme was there. If enzyme was not there, these molecules could not come close together. These molecules could not get proper orientation, and the reaction could not take place in high speed. So this is what we have mentioned here. In case of more than one substrate molecules, the reaction require these molecules to come close together, with proper orientation, direction, so that effective collision takes place. Hence, the enzyme provide environment, microenvironment, proper environment where this goal is achieved. Now the third one is acid-base catalysis. In acid-base catalysis, once again our focus will be attachment of the substrate, proper attachment of the substrate, or the formation of transition state. In acid-base catalysis, some of the enzyme, again this is the active site of the enzyme. We have not mentioned the whole enzyme, only the active sites have been mentioned. Some of the enzyme, they have special amino acids we call residues. They are called serine and histidine. Serine and histidine, these amino acids can act as an acid as well as a base. Mean, if you see here, this is our serine. Serine contain OH. If serine provide its hydrogen to histidine, this is histidine, amino acid, and this is our serine. These amino acids are attached at the active site. This is our amino acid serine, this is our amino acid histidine. The serine is able to provide its hydrogen to histidine. When the hydrogen is provided, then it become like this. Here, hydrogen is in the form of proton, hydrogen plus ion. So the whole histidine will develop a positive charge and your serine will get negative charge. Now you can see very easily that the active site contain negative charge as well as positive charge. So most of these charges have a very great role. As I mentioned in the beginning of this lecture, that the charges, the presence of charges on the active site able the active site to attach with the substrate, because incoming substrate is gonna be attached with the active site, so there must be some charges, some electrostatic interaction between these. So here we have the charges. Now here I use one word, nucleophile. What is mean by this word, nucleophile? Don't worry about the word nucleophile. Nucleophile is a group having negative charge. This is your nucleophile. So we want nucleophile, we want a negatively charged group on the active side. So who will help us creating nucleophile center? Now this amino acid has helped us by accepting a proton from the serine. So here we can see that this one who gave proton is called acid, and the one who got proton is called base. So acid-base reactions, these are called acid-base catalyzed reactions. Nucleophile has been generated, negative charge has been generated. What this negative charge will do? Come here. This negative charge will provide us what? Nucleophilic center. Generate nucleophilic center. This is our nucleophilic center. What is the role of this nucleophilic center? This is very simple. इसके पास नेगेटिव चार्ज है, सबस्ट्रेट आसानी से इसके साथ अटैच होगा. Substrate can be very easily attached here at this negative site. If this negative site was not there, if this nucleophilic center was not there, the substrate molecule might not have attached here. That's why this is the first thing. Stabilized charge groups. What is mean by this? Maybe in the chemical reaction we have some other charges here and there. So these charges may not be stabilized properly. So our charge groups make a bond with these other charge molecules. It will be stabilized. Here maybe we have some other charge molecules in the environment. These charge molecule may make bond with these charges so that they can be stabilized. So this stabilization is the second step. Third one is electric interaction stabilized transition state. I have already mentioned that this is our transition state. If you want this transition state to be stabilized, you need to attach this substrate molecule with the active site for proper time. So this need what? This need electronegative charges. This need positive negative charges. So we already have positive and negative charges. Definitely these charges will stabilize the transition state. Mean when your substrate attaches here, it will be stabilized. Its shape will not reverse. Now the last one is metal ion catalysis. Metal ion catalysis. There are so many enzymes that use metal ion like zinc, calcium, potassium. These are positively charged ions they use. Why the enzyme use these? Because these can very easily lose their electron. So let's suppose we have sodium. Sodium is a metal, and you know very well metal can lose its electron very easily. When sodium loses its electron E, it will develop positive charge. Similarly, when zinc loses its electron, it will develop positive charge. Zinc lost 2 electrons, so can develop 2 positive charge. That is the reason that enzyme use these positively charged ions with itself. So these are called cofactors. These are called what? Cofactors. These are the friends of enzyme because they help enzyme to catalyze a chemical reaction. And now you know very well what would be the need of these charges. Definitely this is your enzyme. Here your potassium ion may be present or zinc ion may be present, and these are the charges. I have not mentioned zinc or potassium, but I have mentioned positive charge. Definitely means that there are metal ions are present. So these charges will provide the same result as provided by the acid-base catalysis. So what will happen? The first one, the charges help in formation of strong nucleophile. Now this is a strong nucleophile. Means if you have positive charge, then the presence of metal ion will make the charge increase in number, so the nucleophilic center will also be very high in number. So attachment will be strong. This is first. Second one is stabilized intermediate transition structure. I have already mentioned that this is our transition structure. If you want to stabilize, you need to attach it for proper time. So these positive ion will stabilize your transition state as well. The third one is hold substrate inside deep pocket. These ions that are present here, these will allow the substrate molecule to go inside the pocket, deep pocket here. Now here your substrate is here, inside deep pocket. It will be stabilized here. It will not come here and there. As far as it is in the deep pocket, it will be catalyzed. So these are the three roles of the metal ions. Number one, strong nucleophile generation, stabilized intermediate or transition structure, and whole substrate inside the deep pocket. So this was our whole lecture. It was all about the mechanism of catalysis. We discussed how an enzyme decrease the energy of activation. The whole topic of today was to give an appropriate answer of this question, how the energy of activation is decreased. So these are the four ways by which energy of activation is decreased. In these four ways, we noticed one thing, that the substrate must attach with the active site. There must be something on the active site so that the substrate could attach. And we also discussed that the substrate molecules, if they are far away from the active site, from each other, the substrate molecules should also come close together so that they could react with one another, so that they could collide with one another. And third one, once they come close together, they must get proper orientation. If they are not properly placed, they may not react properly. They must be properly placed. So who is gonna help them to go like this? The enzyme will position them in proper place. Once these targets are achieved, then we get catalysis. I hope you got the topic. See you in the next lecture.